All right, hello again, pre-calculus people. So today we're going to start a new unit on, well, not really a new unit, but kind of continuing on. We talked about some polynomials and some quadratics, kind of reviewing those guys. Now we're going to get into higher order polynomial functions. And the first thing we're going to talk about in that mode is how to sketch curves of polynomials without a calculator, but still accurately and really see what's going on with how the curve behaves. So to do that, there's three things we have to know. We have to figure out the end behavior, which literally means what's happening on the ends. What is the y-intercept? That's the easy one. And what happens at the x-intercepts, and kind of how to figure out what the behavior is happening where it touches the x-axis. So we're going to do this in three sections. So the first one, so for end behavior, all you got to look at, it's one of two things. It is either, I should say you look at two things. So you look at the leading coefficient, and all you care about that leading coefficient is if it's positive or negative. And the other thing you look at is what's called the degree, and that is the biggest exponent. And all you care about there is if it's even or odd. Okay, and that little bit right there, the leading coefficient and the degree, tells you about the end behavior. Okay, so as I scroll down here, you're going to see a table. I've got there's only four options, right? Because if we got the leading coefficient can be positive or negative, and the degree can be even or odd. So we have four combinations that we can kind of put in here. So even positive. So when the degree is even, like the biggest exponent is 2, 4, 6, 8, whatever, and the sign of the leading coefficient. By the way, I'm usually going to refer to that as LC because I'm lazy. So the leading coefficient, if that's positive, then what does that mean? So in this third column here, we have what's called limit notation. You're going to see this, especially if you go next year to take calculus, and you'll see it occasionally this year too. The way this is read, this top one up here, this says the limit as x approaches negative infinity, which means off to the left. So as x goes to the left, then the function value goes to positive infinity. So really what that means graphically is on the left-hand side, the graph or the function is going up to positive infinity. And then the second line, the limit as x approaches positive infinity. So as x goes to the right, again, it's going up. So on both ends, for the even positive case, both sides are going up. Now, we don't know what's going on in the middle. That'll come later for the y-intercept and the x-intercepts. But for right now, all we care about is what's going on kind of on the ends, hence the term end behavior. How about if it's even and a negative LC? You'll see the limit notation. Now on the left, it's going down, and on the right, it's going down. So kind of like that. Now, this is kind of like the easiest example of this is your old friend, the parabola from Algebra 2. So, because that's an x squared function. If your leading number was positive, it's going up. If your leading number was negative, it was going down. Kind of like that, right? But it's the same case as, again, fourth power, sixth power, whatever, if it's an even number. How about when the degree is odd? So like the third power, fifth power, so on and so forth. Well, now, again, let's look at the limit notation. To the left, as x goes to negative infinity, the function is going to negative infinity. So on the left, it's going down. But on the right, as x goes to positive infinity, it's going up. So this is kind of like your cubic function from your parent function last year, kind of like that. And again, fifth power works the same way. The odd negative case, it's just a reflection of that. So as x goes to the left, the function goes up. As x goes to the right, the function goes down. Okay? So let's do a couple of examples just doing that and just kind of sketching those end behavior arrows of what we have on these polynomials. So letter A. So notice my degree is odd. That's my 3 right there. And notice my LC is positive. Again, we don't care about the numbers themselves. All we care about is even odd for the degree, positive or negative for the LC. So odd positive, you go to your table. Odd positive, we got down here and up here. By the way, if you want to take a screenshot of this, if you want to take a quick little picture, pause the video, take a picture of that table so you have it for future reference, maybe it wouldn't be a bad idea. Now, letter B, degree. Again, the degree is even. And the LC, leading coefficient, is negative. They're usually going to be in order. A teacher could try to trick you and kind of put them out of order, but just remember the degree, biggest exponent, the LC, the coefficient attached to that exponent. Okay? So again, now we have even negative. Look at your table, both sides going down. Got a couple more examples. If you want to pause the video and do those on your own, you can go back and you can go back and refer to that table if you need to. So I'll give you just a couple seconds to see if you can do C and D. So notice on part C, the degree again is even, the LC is positive, even positive, both sides going up. Part D, the degree is odd, 7, and the LC is negative, -4. Odd, negative, up on the left, down on the right. Now the last two examples, the E and F parts, these are a little bit different. Okay, now you might be looking at letter E and going, oh, the degree is 2. No, because remember, we still have an exponent right here of 1, and these are all being multiplied. So when you are in factored form, you have to add the exponents of the x. So in this case, your degree is actually 3, so it's odd. The LC is usually going to be the number in front. We do have to multiply all of the, so there's a 1 here, there's a 1 here, there's a 1 here. So 1 times 1 times 1, obviously positive. So just kind of be careful of all your, all of the leading coefficients, kind of multiply those together. But again, all we care about is the sign anyway. So the odd positive in this case would look like this and like this. And again, if you want to pause the video, see if you can do part F the same way. I'll give you just a second. So for the degree, again, we have a 1 here, we got a 1 here, there's no other x's out front. So add those together, the degree is 4, which again is even. The leading coefficient, notice, is -2. So -2 times 1 times 1 times 1. So it's -2, which is negative. So even negative, like that. Okay, so that is end behavior. Again, know those 4 patterns, because as we get into the full curve sketching in a couple minutes, that's going to help you guys out. Okay, next piece, this goes really fast, the y-intercept. This is the easiest one of them all, I think. So for the y-intercept, all we got to do, we're going to plug in 0 and work out what it is. Literally plug in 0 for all the x's, because obviously if you plug in 0, those are all just going to go away. So if I plug in 0 here, and here, and here, those 3 terms, they're not there. So y-intercept is what's left over, 0, -4. Same kind of deal on the next example, 0 here, 0 here, goes away. Y-intercept is 0, 1. And we do want to write that as a point. Zero here, 0 here, 0 here. So we got 0, -8. And 0, 0, 0, 0. So your y-intercept here would be 0, 1. Okay. Now again, those are super easy. The last two in our factor form, notice I'm using the exact same examples so that at the end we can actually graph these last two, E and F, to see what the curve's going to look like. When you plug in these zeros, there's a little bit more work to do, right? The x's still go away, but really what this is 1 squared times -3, which is -3, so it's 0, -3. Same thing on the last example, plug that 0 in, that 0 in, that 0 in, and then whatever's left over, -2 times -1 times 2 times -2 squared, and just do that math, so that's going to end up being 16. Okay? Y-intercept, plug in all the zeros for all the x's, and just work out what it is. Okay? Now, part 3. And this is our kind of our big finish here. So part 3, the behavior at the zeros, or the roots, whatever you want to call them. Now here's the catch. We can only do this right now if the function is written in factored form, like those last two examples, those examples E and F that I've been using. Okay? If it's in normal kind of standard form, like the other examples, right now we can't do anything with that because we need to be able to find those zeros. In about a week, we're going to know how to find those zeros, so then we can do the curve sketching. But for right now, we're just going to be giving it to you in factored form to determine what's going on. Okay, so here's what we do. We're going to set each factor equal to 0 and solve it, because we know that's our x-intercept from our algebra days. And then we're going to look at the exponent of that factor. If it's even, then it's going to bounce, and we'll talk about what that means in a second, but literally it bounces. If the exponent is odd, it's going to cross at that number. Okay, so let's see what happens. So on this example, again, same one I've been using. In fact, I'm going to go back real quick. So on that example E, we know our end behavior was down and then up. I'm going to kind of jot that down here. So I know down and then up. And I also knew that my y-intercept was at -3. Okay, because I'm going to use that when I go sketch the whole curve. So my x-intercept, you see in the first factor here, this is saying x equals -1, and the second one said it equals 0, x equals 3. So that means the point is at -1, 0. And notice the exponent is 2, which means it is going to bounce at that point. Remember, just the exponent, even or odd. For x equals 3, that's the point 3, 0. The exponent here is 1, so it's odd, so it's going to cross. Okay? So how do we graph this thing? Just graph the 3 points that we know in this case. So I know that I got a -1 on the x, I've got a 3 on the x-intercept, and I've got a y-intercept of -3, so I'm going to put that down here somewhere. Doesn't have to be exact. This is a sketch, but we just want to see what the behavior is going on. Now, when you actually go to actually make the curve, start on the left. Again, just because of my end behavior, I know it's starting down here. Okay, so I'm going to start the curve down here. Then I'm going to hit each point as it comes, doing what I need to do. So at -1, notice I bounce off of that number. So I'm going to start here. I'm going to go to -1, and when I say bounce, I mean bounce. So it's going to come right back down towards your y-intercept. It'll go through the y-intercept. At some point, I've got to come back to my other 0 at 3, so I'm going to curve right back up here. And that is going to be that. Okay, and that's a sketch. That's a sketch of that curve. In class, I will show you on Desmos, and you can graph this on Desmos yourself. Is that exactly 100% accurate? No, but it's a good sketch. It's the same kind of behavior that you would see on a graphing calculator. How about part F? Again, we know the end behavior and we know the intercept. So on part F, the end behavior, both going down. The y-intercept was 16, so I'm going to kind of jot that over here. And then I get my intercepts. So here I know my x equals 1, x equals -2, x equals 2. So 1, 0, cross. -2, 0, cross. And 2, 0, bounce. So I'm going to write all 4 of those points. So I got 0, 16, that's going to be way up here somewhere, close enough. I got -2, I'll put him right here. I got 1, I'll put him right here, and +2, him over here. Okay. I know on the left it's starting down here. So again, I know I'm going to cross at -2, so I'm going to start coming, cross. The next point I get to is my y-intercept, that's just what's next. I'm going to come up here, start swinging down to the 1. What happens at 1? I cross again, so I'm going to go all the way through 1. I know I've got to come back up to 2 somewhere, so right about here, but it bounces, so I'm going to go to 2, bounce off, and then once I hit the last point that I have, I just keep on going forever. Notice the other side of your end behavior happens automatically. If you hit the points correctly, the right side of the end behavior will happen automatically. I don't want this video to go too long. I feel like it already has. But let's do one more example, and then we'll finish it up, and we'll do a couple more examples in class tomorrow. So, if you want to pause the video real quick, work it out yourself, see what the degree, leading coefficient, figure out your end behavior, do your y-intercept, do your zeros, crossing, bouncing, and see if you can sketch the curve. So here we go. Degree. Remember, there's 2, there's a 1 right here, so the degree is odd, 3. The LC is negative. So your end behavior, odd, negative, is here and here. Y-intercept, plug in all the zeros. You got -3 times -1 squared times 3. We got -3 times 1, -3 times 3, -9, so it's 0.0, -9. And then the zeros, we have x equals 1, that's bounce, and we have x equals -3, that's cross. Okay, put all the points in there. Y-intercept -9, I'll put that down here somewhere. X equals 1, by the way, that's the point 1, 0. I should put that point there. Just what the x is. So my point's at -3, so -3 here. We'll put 1 right here. And then you look at your end behavior. I start up here somewhere. -3 is going to be a cross. Come down, my next point is at the y-intercept, so cross there, close enough. The bounce at 1, and the rest of my end behavior happens automatically. Okay, so that's the process of curve sketching. End behavior, know those 4 different situations. Y-intercept, plug in the zeros for all the x's, and then find your x-intercepts, your zeros. Set each factor equal to 0, and then look at the exponent for the bouncing and the crossing. More examples tomorrow. If you need help, come to tutoring. Until next time, stay safe.